DOTD designation TR327 and AASHTO T209, determining the theoretical maximum specific gravity and density of uncompacted asphalt mixtures at 25 degrees Celsius. The theoretical maximum specific gravity test, also known as GMM, is vital in determining the quality of asphalt mixtures. The GMM value is used in all subsequent calculations when determining volumetric properties. These properties are used to calculate the percent air voids in compacted asphalt mixtures, provide a target value for compacted asphalt mixtures, and are essential in finding the amount of asphalt binder absorbed by the internal absorbency of the individual aggregate particles in asphalt mixtures. The precision of the method is best when the procedure is performed on samples that contain aggregates that are completely coated. To ensure complete coating, it is desirable to perform the method on samples that are close to the optimum asphalt binder content. During the GMM procedure, we will conduct 2 GMM tests. According to the application of quality assurance specifications for asphalt concrete mixtures, these 2 tests will be averaged to report a single value. By conducting multiple tests and combining the results, we can increase the accuracy and reliability of our measurements by providing more comprehensive quality control over the asphalt mixture. Listed below are materials needed to perform this test. A 6,000 gram sample of asphalt material in accordance with DOTD S203 from the Material Sampling Manual. A glass, metal, or plastic pyknometer with a volume defined utilizing a glass capillary stopper, capillary lid, or glass plate. A vibrating table or shaker to perform consistent, automatic agitation of the vacuum pyknometer, and a bleeder valve attached to the vacuum train to facilitate adjustments of the vacuum being applied to the pyknometer. A ballast conforming to the requirements of M231 Class G3. The ballast shall be standardized at least every 12 months. For the mass determination in water, the ballast shall be equipped with a suitable apparatus and holder to determine the mass of the sample while suspended below the ballast. A water bath capable of maintaining a uniform temperature to determine the mass in water at 25 plus or minus 1 degree Celsius. A vacuum pump capable of emptying air from the vacuum container to a residual pressure of 3.4 kilopascals or 25 millimeters of mercury. A vacuum gauge to be connected directly to the vacuum vessel and capable of measuring residual pressure down to 3.4 kilopascals or 25 millimeters of mercury or less, preferably to 0. A thermometer to measure the temperature of the water within the water bath. And finally, you will need a thermostatically controlled drying oven capable of maintaining a constant temperature. A key and vital step in testing for GMM is to prepare the sample for short-term conditioning. Short-term conditioning at the specified temperature is especially important when absorptive aggregate are used. This short-term conditioning will ensure the calculations of realistic values for the amount of asphalt absorbed by the aggregate and void properties of the mix. Plant-produced asphalt mixtures should be evaluated to make sure short-term conditioning has taken place during production and delivery. For short-term conditioning, refer to AASHTO R30, Standard Practice for Laboratory Conditioning of Asphalt Mixtures, and DOTD, Applications for Quality Assurance Specifications for Asphalt Concrete Mixtures. Application of Quality Assurance Specifications for Asphalt Concrete Mixtures states that unless procedures require otherwise, the laboratory-produced mix shall be cured for 2 hours and plant-produced mix shall be cured for 1 hour at the compaction temperature plus or minus 10 degrees Fahrenheit. When the aggregate water absorption is greater than 2%, the oven age time for plant-produced mix shall be 2 hours. Once you have your 6,000 gram minimum asphalt sample, your first step is to split and quarter it down to the correct minimum sample size. In this case, refer to Table 1 in the test method DOTD TR327, which requires a minimum of 2,000 gram sample for a 3/4 inch nominal maximum aggregate size mixture. Once completed, collect and pan 2 of the opposite corners of the specimen and place in the oven for conditioning. Remember to obtain another 6,000 gram sample and repeat the process. While our sample is aging, we will get a calibration of our pygnometer as required by procedure. To calibrate, we need to determine the mass of the pygnometer submerged in water at 25 degrees Celsius. We will allow a few minutes for the water to stabilize. Once we get a stable mass on our ballast, we can acquire the weight of the pygnometer in water and record as B. Following the aging process, remove the sample from the oven and place it on a table to cool. Once cooled down enough to control by hand, gently separate the particles of the asphalt mixture, taking care to avoid fracturing the aggregate. Do this until the particles of the fine aggregate portion are no larger than 6.3 millimeters or 1/4 of an inch. Once cooled to room temperature, we are going to zero our calibrated pygnometer on the scale and then place our sample into the calibrated pygnometer. Next, place the pygnometer and the sample onto the scale and record the weight of the mix as A. Next, add water to approximately an inch above the sample. Carefully place the pygnometer on the vibrating table. Secure the pygnometer to the vibrating table by placing the vacuum plastic lid with O-ring gasket onto the pygnometer, ensuring you have a good seal. Make sure your bleeder valve is closed before you start the vacuum pump. Check the pressure gauge to make sure it is moving toward 30 plus or minus 5 millimeters of mercury. Once you are below 30 millimeters of mercury, turn on the vibrating table, initiating a vacuum period of 15 plus or minus 1 minute. Set a timer if needed. At the end of our 15 plus or minus 1 minute vacuum period, release the vacuum through the bleeder valve by increasing the pressure at a rate not to exceed 60 millimeters of mercury per second. Your lab may be equipped with an auto rice controller. This controller will automatically turn on the shaker table and set a 15-minute timer when the pressure is below 30 millimeters of mercury. The controller also has an automatic shutoff feature when the 15-minute frame has been reached. In addition, the controller automatically releases the bleeder valve, not exceeding 60 millimeters of mercury per second of increased pressure. If not equipped with an auto rice controller, this can be done manually with a fair amount of precision and caution. Next, release the pygnometer from the shaker table. Having vacuumed and vibrated the sample for 15 minutes, we can be assured there are 0 air voids in the asphalt sample. At this time, make sure our ballast is zeroed out. The water temperature is at 25 plus or minus 1 degree Celsius, and the water is up to the overflow outlet. Place the pygnometer onto the suspension apparatus and slowly immerse it onto the water bath for 10 plus or minus 1 minute. Determine and record the mass as C. We can now go ahead and calculate the theoretical maximum specific gravity, or GMM. The calculation for GMM is A divided by A plus B minus C, where A is the mass of the oven-dried sample in air, B is the mass of the container submerged in water, and C is the mass of the sample in container in water. For our first sample, we have 2,159.3 plus 1,344.1 equals 3,503.4 minus 2,585.4, which equals 918. We can now go ahead and take 2,159.3 divided by 918, which equals 2.352178. So we have a theoretical maximum specific gravity of 2.352. For our second sample, we have 2,161.6 plus 1,344.1 equals 3,505.7 minus 2,586.9, which equals 918.8. We then take 2,161.6 divided by 918.8, which equals 2.352633. So we have a theoretical maximum specific gravity of 2.353. We will now calculate the average GMM by adding our two samples together and dividing by 2. So we take 2.352 plus 2.353, which equals 4.705. Then take 4.705 and divide by 2, which gives us 2.3525. Our average GMM value is 2.353. This will conclude the theoretical maximum specific gravity of asphalt concrete mixture LA-DOTD TR327 and AASHTO T209. Listed here are the review steps for this procedure.